For today's webinar, I'm excited to take a slightly different approach with our application. As many of you know, at the end of the webinar, I have a feedback link where I have a QR code that you can scan and submit feedback. And one of the feedback submissions that I get on occasion is that they love the format of the webinar, but can you take us through a entire workflow? And while the scope of the webinar generally is built around the idea of showing successful projects that are very large ones, right? That I wouldn't be able to do that with, which is why we take the approach of rolling back through history, and then I stop at different points in the history to show and give tutorials based on those specific key moments in the workflow. So that is the generic template that we are following for the webinar, but I do want to mix in, exactly like the people are suggesting, some beginning to end workflows where I scan a part and take it through the entire process to a model. And today's is the beginning of a two-part session. So today is going to be part one of the scanning and processing, and the part two will be next week as we follow up. And what I did with this one, because another challenge with doing these presentations is many people have lots of scan applications, but not always am I allowed to talk about them, like if they're customer sites. And we always try to ask for permission in any scenario where we would want to share data. So a lot of my applications here are ones that are openly shareable, ones that I'm allowed to show. Well, this one is actually a personal one. So let's go ahead and jump over to it, and I'll kind of explain a little bit more. So as you can see on screen, we have a commercial product where a family member of mine knows my career path and knows what I do for a living. And they suggested they had a coffee machine that broke on them. And they loved the frother. Now, I know this is funny, right? Okay. This is not necessarily a do we have to do this project. This was more of a fun project with a family member of mine that is very interested in the technology. So we took this coffee machine on the left that had a problem with it, and the frother portion of it still worked and worked well, right? So as usual with these integrated type units, if one part breaks, then you have this giant coffee maker and you only want to use the frother. So he had the idea, how about you take the frother out and we pull the wiring out of this coffee maker, stay with me here, and print out a piece to separate the frother from the original assembly. And upon opening it up, we could see that it was very easy to separate the two components of the coffee machine and the frother machine. So today's session is just talking about how I went about scanning this part, because I scanned an assembly and I assemble it together. And then for the reverse engineering part, the key thing that I like about that workflow is that I modeled from an assembly of scans to make a condensed part for additive, for printing, right? So I combined a bunch of pieces together and made a very simple part that would still house all the electrical components and print that as one piece that would still maintain the functionality. And then when we printed the part, many people can't even tell that it's actually a printed aftermarket part. So part one today, again, is showing how we scanned the assembly, and then how I piece the assembly together of scans. So I actually scanned the entire thing and then I put it all together, which I'll explain as we jump over to Design X. So with that, I think I've talked too much. Let's jump over into the Design X package, and I will start off with showing how I scanned it. So as usual, we always start out by just going over this slide, and I will pare it down. As a lot of people are watching my webinar on a regular basis, I know that going over this slide could take a few minutes, and it's redundant for you. But I just wanted to make sure that anybody that's watching this for the first time understands what Design X is really quick before we dive into the application. But Design X is this software right here. It's the software that we use. It is a software that can work with 3D scan data from a variety of different inputs from different devices like these over here on this side, from structured light scanners to laser to handheld laser structured light scanners, time of flight scanners, CT scanners even, all kinds of different devices. We're creating this type of data and people were trying to load it inside of CAD, and we're struggling a lot because CAD wasn't designed for this type of information. Enter Design X. We create this software that is a parametric CAD modeling kernel with a 3D scan kernel all in one space, right? So then we take this data, do the heavy lifting, and then we extract model information and output it in different sources like you see on the right hand side, whether these are the high level outputs. CAD is the primary, but we also go straight to CNC packages or straight to additive technologies out in the market. So that's what this Design X product is all about. Grabbing that scan data, recreating or reverse engineering that object, and getting it out to whatever is going to produce that manufactured model. So with that, we'll go ahead and jump right into the Design X portion. So now let's go ahead and jump right into the actual application here. You see here that I have Design X open, and I'm going to select the Hexagon Absolute Arm and hit connect to it. And this is assuming that you have RDS installed and everything. Now I'm going to go in and just show you where all the settings are. So if you click on settings, you can see here we have a bunch of different settings. I am honestly, for this project, just going to use the default settings. I just am coming in here to show you where they all are and how you could get to them, and even the hardware settings are in there too. So once I have those settings set, now I can just click Live Capture and throw the part down and start scanning. So now you see that I'm scanning the part. You'll see that this is only the base. We determined that all the electric components that we needed, or everything, was in the base. So we took the top of it off. And this base actually has an assembly of components itself that's still assembled mostly. So what I'm going to do is scan everything as an assembled piece here, capture it from all different directions. And this is going to be my master scan of the existing condition of the part, right? And what we're going to do here is, once I scan the entire assembly, I will then scan each individual piece. Now, if I scan the assembly and then I flip it over, and that's what we're going to do next, is flip this part over to capture the other side, and then scan each individual piece, scan from the top, flip it over. That might get a little bit boring. So for today's webinar, I'm just scanning the masterpiece and then a couple of the components so you can see how you would go about doing it. But the rest of it is going to be rinse and repeat from there. So we see here that I captured from the top direction. Once I'm done capturing the scan from the top, I will leave the plugin and I'm going to select the scans over in the tree. So you see here, that's the scans from the top direction. And I'm going to shift select all those scans and group them together. So now I know that this top group of scans is grouped together because every time I push the trigger on the arm, it will capture a new scan. So now I'm going to flip it over and scan the back side. Now, in this instance, because I'm recording this, there are different approaches on how I would scan a part. On this part, I honestly would scan it flat and then flip it up on its edge maybe, especially since I don't need the whole back side, and scan both sides and piece it together. But for the sake of videoing it and trying to video and show you how this is all happening, I don't have a studio set up, so this was the easiest way to kind of demonstrate. Now I'm scanning the back side, and there are times where I might scan not just a top and a bottom, but a top, a bottom, and then sitting up on the edge like that. And then in crazy projects, you might have 4 or 5 scan setups, right? It just depends on what you're trying to do. So you see now I scanned the top and the bottom, and off camera, I also put it up on edge that I couldn't video very well. And I went ahead and grouped all these scans together. So now I have an easy way to identify this is setup number 1, this is setup number 2 for component number 1, right? Now I'm going to take one of the components off and scan the cavity inside. And I even use that component to prop it up a little bit. Scan the cavity because that cavity is going to be where some of the electronic components go, which we'll cover more later when I get into the reverse engineering side. But what I'm going to do here is, again, scan as all together and group those and merge them together as a piece, and then scan individual components and align them and merge them together. So that way I have this scan assembly that I can work with. And to be honest, during this stage of the project, I wasn't even 100% sure of how I wanted to model the component, the new piece that is going to become the coffee frother. But I knew that if I had all the components in 3D, I could successfully model what I want and merge and cut away and create one solid piece that then unifies a bunch of these components together that also mate with the electric components to then reuse the cord and all those different things later on. So you can see here, I'm over scanning too. I didn't need I needed the cavity. I didn't need the whole back side, but sometimes it only takes a minute to scan a little extra to help use that for alignment purposes to piece those components together. So then we go ahead and get out of the plugin again, group the scans, and rinse and repeat over and over again. So this is kind of how you would do a more elaborate project versus just scanning a part, flipping it over, and scanning again. Again, we're just doing this over and over again because we are going to scan an entire assembly of pieces. So now that I have that, I'll go ahead and scan that component that I took out, that little cover, scan it. And then we're going to be able to merge that as well with the rest of it, or align it together. So now you see here, I threw down the part, move the assembly. You can see that's what the part looks like there. And again, there are different ways. A lot of times I will scan, flip to the side and piece it all together is kind of my workflow, generic workflow here. So once I have that component, go ahead and hit scan, go back in the plugin, and capture this piece too. So all in all, this process of actually scanning everything for the project, right, without editing some of this stuff out, it only took an hour. And that's, remember, scanning, flipping of the entire assembly and each component. And you'll see later on how many components that I have. I was able to do it all in less than an hour for the capture portion. And the only reason why it even took that long is because I'm doing something a little more elaborate than your typical scan a part and model it, right? Because in here, I'm actually taking an assembly and designing a merged component together. So let's go ahead and jump into the stage where we align scans together and merge them. So now that I have all of the scans, I'll go ahead and show you everything here. Turn them all on. I didn't show everyone in the video. I just showed scanning certain parts. So let's go over them first, and then we will take it from there. So I'll just do a click and drag down on the eyeballs. By the way, that is a shortcut that I've explained a few times here. And that is a shortcut trick here that is awesome inside of Design X. If I click and hold and drag down, up and down the eyeballs, click and hold and drag all the way up the eyeballs, you'll see how it turns them on and off. So you see here, in this instance, the way I actually scanned it is I went ahead and scanned it from the top, and I even wrapped around the edge from the top scan of the table. So there's part number one. I called it full part number two. I scanned it, I flipped it over, and I wrapped around the edge as well. Now, I went ahead, and this is some of the parts that you didn't see in the original video because, again, I scanned from the top, scanned from the bottom. Then on this one, I went ahead and did a unifying scan from the side. So I have a bunch of scanning toolbox things around, and I also have this wire that I use as well. I also have clay. There's all kinds of really neat clamps, vices, all kinds of different things to help scan parts. This is just what I had near, and I grabbed a piece of wire and I just propped it up because this is just a unifying scan of unifying one side to the other, and it's not. I didn't do the best job on that one. It's not my proudest scan ever. Then I also took the entire back off and scanned that component there. And then I took that back off and I scanned it from the top and bottom as well. Because again, at this stage of the project, I wasn't even sure. And then I did a flip op for the bottom. I wasn't even sure 100% how I wanted to go about modeling it. And then you see here I have mount 1. And then let me rename it. It's bothering me that I didn't put mount 2. So there's mount 1. This is actually the electric component that forms the connection, and it has pieces in here. I reused the actual piece that I put in the final assembly. In this instance, what I did want to do is take that mount and scan it from the top and bottom. And again, all I was using, I did this scan just for reference, so I didn't get tons of coverage on it. I just scanned it from multiple directions, and I'm using this for reference because this is the piece I wasn't going to redesign. It was going to slide in my new assembly and go from there. So with that, that's my explanation of the components. Let me cover how I merged some of these components together. So you'll see here that the top and the bottom. The first thing I tend to do is, in this instance, a good rule of thumb is to go ahead and do a clipping plane with the arm, which I'll cover that in a future video, how to do a clipping plane so it doesn't scan the table. But in this instance, I didn't bother doing it, and it's okay. You don't have to use the clipping plane because it only takes a couple seconds to do something like this. And select and delete all the components. Especially if you're over scanning, you have plenty of data there to be able to select and delete what's there. So you see there, I just went ahead and I took that scan and I cropped the table away. It only takes a second to do. And same thing goes here. We'll go ahead and hide my planes as well. And select those and delete those. So now we have the top and bottom cleaned, right? And basically, I rinse and repeat all of that for all the way through here. So I'll do one more just to show you here. Over here, I'm basically just getting everything ready to go align, because that is the next phase in this workflow, is to go ahead and align all my scans together to each other. So what I always go through my tree of original raw scans, and I go ahead and I do this process where I just remove any unwanted data that I don't need, and I just cycle through them. Again, it usually only takes like 5-10 minutes or so to do this, and once I do it, I move on to that next stage of aligning together. So let's go ahead and jump forward to that so we don't bore everybody to death just by editing scan data for an entire webinar. So now I have all of them edited and cropped down to just the pieces. Oh, I missed a little piece right here that's just bothering me. So we'll just go ahead and delete that. So we'll go ahead and turn on the top and bottom and piece those together. So if I come over to alignment, align between scan data, and I say local based on picked point, and say part number 1 here is going to be reference, and part number 2 is going to be floating here. And then I can rotate the part around so they're oriented in the same direction, and then click at least 3 points, right? So if I just come over here and just generally, I'm just clicking right off the edge there. And sometimes I'll click 2 at once right in that same area. We'll click over there too. And then we'll click. So you see here, I actually clicked an area that's maybe not the best because I wasn't looking at the same time. So I can hit undo and click right there somewhere around that area instead. Although I could just, select another area altogether to use, right? Versus doing that. You kind of want to spread out like table legs. You don't want to like pick all 3 in a straight line. So one thing to do, I could do right next to that P right there. Again, this is all like, it all depends on the geometry itself, right? So in this instance, I have plenty of overlap. I just need 3 rough points and it'll lock it all together pretty well. So if I hit apply, it'll go ahead and calculate for a second here, and then you'll see that it finishes and they're aligned together. Now you look in here, it's locked in. Now I can also run a global find here, select all, actually just shift select both of these, and then hit apply. And then once that's done, you can just verify that all of this is aligned and it's good to go, and I hit OK. So now we have part number 1. This is component number 1, which is the full thing. I'm going to go ahead now and just jump over to polygons and merge these together. Now, I have 2 different ideologies behind my polygon merging, or my merging. One of them is use volume merge, and the other one is use HD mesh construction and merge those together. With HD mesh, this is kind of my recipe right now, is I will move this up 1 notch, move this up 2 notches, and this down lower. Sometimes I'll move this back and forth here. And that's kind of my recipe. And I also turn off remove original scan data. I want to keep that until I'm positive that my merged scans look good. So now I'm going to select my meshes and say I want to do a HD mesh construction and then hit OK and let it calculate. And this is one of the faster algorithms. That's one of the reasons why we like HD mesh construction. It's the most modern one. It was designed for more long range data merging, but it works very well on small scan sets like this. It's lightning fast. It's probably the fastest algorithm in this list. But it originally was designed for long range data. So now that you see it's aligned, I will hide the original scans. And because we put the rename now in the right click menu, I like coming in and renaming and making this so I know that it's called full part, right? And so now take a look at this, zoom in here and see how clean that scan merge is. It's absolutely gorgeous. And I didn't even crank it as high. Like obviously you can crank it higher to preserve more detail. This is absolutely perfect for what we're trying to do here. I don't need to go crazy with the over processing scan data to get every micron of accuracy out of it when I know that I can reverse engineer this exactly how I want it without trying to split an atom over here, right? Like overthinking this. The defaults so far is what we've used, except for in that merge where I cranked it a little bit higher. So again, part number one, part number two, this is essentially rinse and repeat. So actually, I just accidentally clicked the wrong ones there. Cover two, and this one I did 3 scans. So you see there, I go ahead and I load those up. Save my file. Sometimes I revise my file where I'll do a save as and do scan 02 or whatever. That way I'll have the old data before and after, like a major update or major command here. So now we'll go ahead and say cover number 1. And with this one, and for the moving, instead of using cover number 2, because those are the two opposite sides with very little overlap, I'm going to use cover number 3 because this is the joining piece. So if you wanted to like just expedite this process and make it as streamlined as possible, you might want to just do your connector scan first, and that is the one that you start with, and then you align the other two, and you don't have to remember which one is which over here. But maybe I'm just overthinking it. It's not a big deal. You can just click those two different locations, and then I'm going to click over here. So you see those are all aligned together. Remember, we have 3 things showing over here. So I still have that other scan showing. And then now I'm going to come over and say moving is this guy. Flip this over, rotate it around. This is where, again, I love the 3D mouse. And you'll notice, like, I could do 1, 2, 3, 1, 2, 3. And if you're good, do it. But sometimes I just get my colors out of order, my points. So you can say click, 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 click down here. But you notice I go 1, 1, 2, 2, 3, 3. Because when you do this all the time in repetitive tasks, sometimes you just slowly don't pay attention, right? And then you get them slightly out of order. So that's why I do it that way, is I kind of just like try to dummy proof it for myself. So when I zone out or whatever, I'm not doing it incorrectly. Now this one, I'll go ahead and run that global fine on all of these. And by default, we have reliable scan data. I think these are the defaults right here. I'm just going to run them with the defaults there. apply only small transform, use only reliable data, and as long as the alignment gets better, we are good to go. So that still looks beautiful. And now we go back over to polygons. Now, for this one, I'm just going to run the other algorithm because let's go ahead and talk about it. So my defaults for volume merge are to select the scan days, move it all the way, all the scan data, move it all the way to one away from the highest, and then also turn off remove original data. Select all of these, and you'll see here you have to do it afterwards there, and hit OK and let it calculate. This is a pretty quick algorithm too, by the way. So you see that it is already done. This scan was smaller than the other one, by the way. So it finished faster than the other one, which is probably the fastest algorithm, but at the same time, it was a lot smaller data set. So look at that. Pretty good, I think. Now we had some stuff in there. I didn't really focus on trying to squeeze every micron of scan quality today. I have a home setup where I am not on a fixture table. I'm on a dining room table scanning with a setup that is not approved. So that is another factor here. But you see, I calculated a pretty good mesh here, even so. So now we're going to keep on moving and go from the inside to the inside and align those together, and the mount and align those together. So instead of making you watch that, I'm going to go ahead and just fast forward to the next section, and we will take up the next section, which is aligning the scans to the world and to each other as an assembly. So now we have all the individual pieces merged together. You see here? All of them merged together. So my process here is I'm going to take the full part and I'm going to align it to the world coordinate system. And after I align it to the world coordinate system, we will then align all the other pieces to it. So the way I did it, there's a whole host of ways like you could have, that are acceptable. But this is the main focus, right? This component right here is the main thing. This mount where the component sits on here and makes electrical connection here is what I want to use to create my coordinate system. So what I'm going to do is I'm going to go ahead and take this guy and select all of these pieces here. There we go. All of that. And I like to just create a region out of them. And then come over and say, I want to create a rotational axis, a revolving axis from that. So there, we calculated a revolving axis from that. Now we're going to jump over and create some other construction geometry to use here. So the next thing that we're going to do is create a region for this flat plane here. As you can tell, I tend to like to create regions manually, by the way. So you see here, create a region here. I'm going to add that to, and say insert region. Now we'll just click on it, just make sure it's listed as a plane. So right now, the general idea is I calculated an axis and a plane. So now I have a point that I can construct from those two. Now the only thing I need is something to clock it, clock it around this direction. I can use these sidewalls or this. Like there's so many different ways you could do it. There are tons and tons of ways. For this webinar, I'm just going to select this plane. insert, and just double check that it is a plane and use it. Now you can use sketch information, regions, uh, reference geometry, modeling, CAD model information to use selectable for alignment. So what I'm going to do now is just come over to interactive alignment. I'm going to say we want to move this, hit next. And I like to just move this off to the side. And it's going to say, where do you want with XYZ position? Where do you want to put 0? I am going to say at the intersection of this axis and that plane. So you'll see that the coordinate system now is at the intersection there. I'm going to say the y-axis, I am going to assign it to that axis and then flip it because it's going the wrong direction. And then I will say the x-axis, I want it to, do I want x or z? Say x-axis there. So you see now I have fully constrained it, hit OK, and go align, boom. We have my coordinate system. All 3 planes are at the center of this. So now I can turn my regions off. I have all of those scans now that I need to align to it. So I can come over here. And if I want to do them one at a time, I can. So I'll just do a zoom to fit. And that one will wait till the end here. Let's do some more of the obvious ones here. So let's do inside cover. So now, actually, let's just take it by order. Let's just do it by order. You don't have to. So align between scan data, points, what we've already done so far. So there's my master reference. This is the piece. So I just come in, zoom in there, orient my scan, and hit undo there. Just zoom to fit. Actually, I just like deselected it there by hitting undo. All right, so go back in here, and you'll see that I got to rotate it to the other side. I had it on the wrong side. It has the screws in. This one doesn't have the screws in. So basically, make sure that I don't use those areas. And I'm zoomed way out. You'll see that even this should be good enough to get it. If you want to add an extra somewhere, you know, you can always do that. Just put one right in between here and there, like so. Then hit the apply and come over and double check it. And if I want to double check it outside of the tool as well, I can come in and turn off the part. And you see that it's turned on there. Now, another thing that you can do to kind of check where you're at is come over to view clip below plane. And if you want to look and see how accurate that is, look at that. So one is the scan there, dipping down. So very, very accurate there. That piece is locked in. And then don't forget to turn that off so your view clip here stays on. So we align the first one. Hit OK, get out of the view clip. Let's go ahead and turn on the inside. And come over to align. Actually, the shortcut for alignment is in there as well. So reference is my full part. Moving is my inside. I didn't click local based. So rotate this around. We're going to be using the back. Now remember, this has got the cover missing. So we need to just use common areas. Something like this, which should be pretty good. Just selecting these four corners. Like that. I come over here, grab that. And hit apply. So just like before, if I hide my main piece, you can see the overlapping areas. You can kind of see there. And if you slice the section through, we'll double check all of the alignments afterwards too. So I'll go ahead and turn that off, turn on the bottom, hit save usually before I move on to the next one. And now I can just plug these all in at once and do it. But sometimes if you're trying to be very careful, you just deliberately do them one at a time because you are maybe you're not 100% sure how well they're going to fit together and things like that because of the scan data. But here we go. And take that refine alignment. See, after you do that, it always has a refine alignment, which in my experience is very good. That refine alignment that happens after is very accurate. And then we'll turn on mount right here. And basically, I'm going to use this. Yeah, that. And then we will come up top. And we'll use that. That should be good. Rotate that around here. Double check it. So now we have this crazy assembly here. So there's that. If you want to turn on the other pieces here, you'll see all the other components fitting together. Now you see how that back piece, this piece, screws in, and then it's got this surrounding ring here that is used to push this and drive this into the top assembly, push this into the hole that's here. Right? So now you have this scan data assembly put together that's ready for us to reverse engineer and create a part that we can go ahead and print. So I'll go ahead and save and basically wrap up today's portion is part one of a two-part series that I wanted to do. Again, kind of wrapping up, I get requests to do more hands-on, step-by-step workflows, and I try to save you some of the agony of just watching somebody click and move around with something like this, to where I'm showing the highlights and you still get a tutorial on how to go from one place to another. So in this project, we took it from concept to scan to now assembly of the scans, and then we will cover the reverse engineering in part two next week.